Okay, so we have a system of equations. One of them is a linear equation, another one is quadratic, and we need to solve this system both algebraically and graphically. So let's start by substituting x squared for y in a linear equation. So we will have x squared is equal to 3x plus 2. Now we will subtract 3x plus 2 from both sides of our equation. So we get x squared minus 3x minus 2 is equals 0. Well, now we have just a quadratic equation of a standard form. So let's find a discriminant. Discriminant is equal to, let's review the formula for discriminant. It's b squared minus 4 times a times c. B is a coefficient in front of x, so negative 3 squared minus 4 times a is a coefficient in front of x squared, so 1. And c is this number, so times negative 2. Well, negative 3 squared is equal to 9. 4 times negative 2 is 8, so 9 plus 8, and we get that our discriminant equals 17. Now let's find the roots. X is equal to negative b plus or minus the square root of discriminant over 2a. Well, let's substitute the numbers. So negative b is 3 plus or minus square root of 17 over 2. Now we'll just use a calculator to find these values. So x1 equals 3 plus square root of 17 over 2 is equal to 3.562, and x2, where we have 3 minus square root of 17 over 2 equals to negative 0.562. Now we just need to substitute these numbers for x in our second equation. So in our quadratic equation, y is equals x squared. We just substitute these numbers for x to find y. So y1 equals 3.562 squared. That means that y1 is equal to 12.685. Similarly, we find y2. It's equal to negative 0.562 squared, and we get that y2 is equal to 0.315. So we have two solutions of our system of equation. The first solution is negative 0.562 and 0.315, and the second solution is 3.562 and 12.685. Well, great. Now let's try to find the same solutions graphically. To do that, we need to graph the line for our linear equation and also the parabola for quadratic equation. Let's see how we can do it. So part 2, I'll just copy paste it. Well, so we start by building xy plane. xy plane. Let's start by building the line. So by graphing our first equation, y is equal to 3x plus 2, we know that to build a line, we can find 2 points, and this line will be defined by these 2 points. So we can just construct the table of values. So x and y is equal to 3x plus 2. For instance, if x is equal to 0, then y would be 3 times 0 plus 2, and this is equal to 2. Then if x is equal to 1, then y would be 3 times 1 plus 2, which is 5. Well, let's let's draw these 2 points. So let's say this is 1, this is 1. So the first point, x is 0, that means that our point is on y-axis, and y is 2, so our point is here. It's here, 0, 2 point. Another point has x coordinate being equal to 1 and y coordinate being equal to 5, so it's here. 5, 1, 1, 5. Well, and now we can build a line by just connecting these 2 points. Let me do it like this. So this is a graph of our first equation. So this is the graph of y being equal to 3x plus 2. And now similarly we will build the graph for y being equal to x squared. Again, let's write down, let's construct a table of values. So x and y is equal to x squared. Again, for example, for x being equal to 0, y is equal to 0 squared, which is 0. For x being equal 1, y is equal 1, and for x being equal -1, y is also equal 1. Parabola is defined by 3 points, so these 3 points are enough for us to build this parabola. Let's draw these points on our x and y plane. So the first point is 0, 0, so it's the origin right here. Next point is 1, 1, right here. And another point is -1, 1, which is right here. Well, we have these 3 points now. We need to connect them smoothly to build our parabola. Let's try to do this. Here. To find the solutions graphically, we just need to look at the points of intersection. So we have 2 points of intersection right here and right here. So we cannot see the numbers clearly from our graph because the solutions are not integers, but we see that those solutions which we have found in that part where we looked for them algebraically correspond to the solution, to the intersection points on this graph. So the solutions of our system of equations are this.